Welcome to the Marshall News in View show. My name is Elaine Conyers, and I have a very special group of Marshall High School students here right now, and their instructor, John DeCramer. And they're going to tell about their experience in this extracurricular activity that they do here at the high school, and that is learning how to run robots. Now, I was introduced to this guy, and he kind of started chasing me, and I didn't really know what to do. But anyway, well, this group is called the Tiger Bots. Is that right? The
That's
Tiger
right.
Bots, and they're a very special group because they were just at state competition, and they placed
16th in our regional.
16th in the so it's just wonderful. And we just wanted you viewers out there to see all of these wonderful things that Marshall High School offers. And with that, I'm going to turn it over to John, who will ask the students to do something with this robot. But first of all, I do want to introduce the students themselves. So I'll start over here.
Hello, my name is Chichi Wakaba. I'm a senior in the second year of robotics, and here's a robot. Here you go.
I'm Monica Timmerman. I'm a senior, and this is my 4th year in robotics.
I'm Sophia Bicey, and I'm a senior, and this is my 2nd year in robotics.
Hi, my name is Sabrina Peralt, and this is my 1st year in robotics, and I'm a junior.
David Black. This is my 2nd year in robotics as a 10th grader.
I am Mary Jean Porter, and this is my 2nd year of robotics as a sophomore.
My name is Jet Scry, and this is my 2nd year of robotics, and I am a sophomore.
And I'm John DeCramer, and I think this is my 9th year in robotics as a mentor. And we won't get into what senior is on my account, but this is, as we were saying, the Marshall Robotics. We are part of what is referred to as the U.S. First competition, and that is a global organization that sponsors and provides all the necessary background work to put on competitions throughout the United States. Right now, there's 203 robotics teams in Minnesota, and after our competition, we are actually ranked 61st in the state for this. We competed in the 10,000 Lakes Regional at the University of Minnesota in the first part of April. And with that, we placed 16th in that, and were able to take part in the finals up through. We made it up through the quarterfinals. Didn't quite make it into the finals, but we had a great time. And I think I'll turn it over and let the students talk about the robot.
Okay, very good. And show us how it works, right? I'll stay out of the way.
Well, the robot is driven by motors. We've got 6 of the larger motors called sim motors that drive the 8 wheels at the bottom, 4 on each side, the 4 pickup motors in the middle center, and then the spinning wheels at the center.
Should talk about the task itself. What was our competition this year?
For First Robotics, we usually have different themed competitions, and each theme kind of determines how we build our robot and what it usually does. So this year, it was First Stronghold. So our task was to build a robot that can scale a tower, shoot at defenses, and shoot to make goals, and just climb over obstacles and either push doors or pull down doors. So we built our robot in mind to shoot at the higher goals and at the lower goals, but we had a little bit of an issue at the competition, but we managed to fix it to where it would shoot at the upper goals, and we would be able to go through some of the terrain, but not all of it, which was fine because we were on teams with 2 other people, and they usually either had gotten those defenses down with us, with our help, or for us. And we just the entire competition was kind of a team effort.
As far as construction goes, we use some pretty interesting techniques and materials. The curved backplate for our launcher was made from a single piece of aluminum tubing, which we pushed through a very neat mechanism that we used to bend it in a continuous piece. So that's how we got a very nice curve with that. The frame itself is welded aluminum with the drive wheels all bolted on. It's mostly bolts except for the main frame. It's a very sturdy, very stable design.
So when we go to competition, it's not our robot against another robot, but you get put on teams. So it'll be you and 2 other schools and their robotics clubs, and you guys work together on your side to accomplish the task. So often you split up the tasks. So our robot, as Mary said earlier, we focus on shooting in the big goals. So we would do that, and then the other 2 robots on our team would work with us to take down defenses and then get to the other side. And First Robotics does a really good job of promoting working together and teamwork. And so at the end, also part of earning points is everyone in your team getting to the end and going up on their tower, I guess you would call it.
All right, so beyond building our robot, we have to program it as well. And for shooting the robot, one thing we focused on programming is to be able to get our robot spot on to know where we're shooting. So the black piece right here is a camera that allowed our driver to line up and make sure that he was directly in front of the goal, so he was shooting straight on instead of to the side. And in addition to that, we had a sonar sensor that picked up how far we were from the goal, so our driver was able to make sure that he was in the correct range. I think we found out that 6 to 8 feet was the perfect shooting distance from the goal, so that allowed us to raise our probability of making the goal every time, and we had like 4 out of 5 shots we'd make.
So building a robot comes with teamwork. So this year we tried something new. We divided ourselves into different teams. We had a team that worked on engineering, so building the robot, and then we had a team that did designing of like t-shirts and a flag, and then we also had another team that focused on programming.
Last year, I was the Tiger Bots mascot, where I was dressed as a tiger, jumping around, working together with other mascots so that the competition is fun and just enjoyable for all the students. And then this year, I didn't have a chance to go to robotics, like state robotics, but my whole Natalie was a good, excellent mascot who, even though she's small, she's pretty enjoyable, cuddly, and awesome. Now let's just move to the computer where the driving happens. Want to talk?
Well, the robot is driven through a thing called the driving station. 2 parts to it: the actual controller, which in this case is an Xbox controller, and the laptop, kind of the brains part of it. The program that's running right now would be considered the driver station program run by LabVIEW. The 3 lights there indicate that we have communication from the joystick, the robot code, and then communication with the robot. The robot and the driver station communicate via Wi-Fi signal. So in order to drive the robot, you've got 2 options. You start the competition. Yeah, you start the competition with autonomous, which means that the robot drives totally by itself. It's just a pre-programmed maneuver. And then after that is finished, you go to the teleoperated period, enable it, and now the robot should move. It's live, so anything that you hit here will drive the robot.
You want to give it some room. Take a run down the hall again.
something about shooting.
I'll catch it.
Do you want to pick up the ball too?
Yeah.
Should we take the ball out quick? And then
Yeah, so take the ball quick.
You make it look so easy.
All right, so our main goal is the first thing we'll do is we can pick up the ball when we come on one. So Jet will pick it up after Chi-Chi throws it. And there's wheels inside that roll the ball on up into the robot. And then it kind of sits in a spot where it won't yet get caught in the shooting wheels, so the wheels can get up to speed before the ball is there. And there's another small wheel in the robot that pushes it so that it does get caught by the shooting mechanism. So now you can see what it looks like when we shoot the ball out of the robot.
Try it again.
And then I will mention here, if you look on the sides, there's 3 wheels on one side and you only see 2 on the other. In our final round of competition, we did end up breaking one of the wheels on the side, and we didn't have enough time between rounds to completely replace the wheel, so I ended up just cutting off the outside. So the robot is a little more unstable now than it was before, but yeah.
Running? I guess a number of the things we want to stress with the whole robotics program is really the use that the students get of really working with all the STEM type of education system. That's the science, technology, engineering, and math. We had a lot of math to figure out and getting the trajectory of the ball figured out, the radius of the shooting mechanism, the speed of the mechanism, as well as doing the engineering, the design work, the CAD, and the programming. And we get involved with all different types of aspects of the STEM environment. One of the things that this really is for is to involve the students in getting an experience of careers that can be right here locally in Marshall that involve projects of this nature, maybe design work, involvement of construction, of maybe mechanical or electronic, and usually a combination of different environments coming together. Yeah, it's really, yeah, this is taking a beating. We do have a few things that are not working right now. Yeah. Fortunately, the drive is.
Broken on the other side too. If you watch as it turns, they come out in the wide move.
All right, our next quarterfinal match. We have Alliance number 2, Alliance number 7. Let's start with Alliance 2 and our Alliance captains. These guys are in their second year, and they're Alliance number 2 Alliance captains. Here for 54-34.
From Faribault, Falcon Robotics.
The team that is wearing their bow ties a lot longer than I did, 31-97.
Cedarburg, Wisconsin, Hex Hounds.
And coming out of the on-deck circle, backup team, now part of the number 2 alliance, 25-15.
From Marshall, it's Tiger Bots.
All right, let's meet our number 7 alliance. Digging in the dirt, right? 45-49.
From South St. Paul, it's Iron Bulls.
They are joined with 28-55.
From St. Paul, Minnesota, Beastbot.
And a tip of the hat to 32-44.
From St. Cloud, Minnesota, Granite City Gearheads.
Drivers behind the line in 3, 2, 1, charge.
And charge they do right over the defenses to get them weakened in ones. 32-44, looks like they take a shot. Oh, and we got a high goal for the Red Alliance, Falcon Robotics. And Red takes a 32-22 lead after the autonomous. Tiger Bots coming over to the blue courtyard to play some defense. High shot taken by Falcon Robotics. They miss it. Oh, 45-49. Looks like they're stuck on a ball, but they got off. There we go. Good alliance partners here. Hex Hounds puts one into the low goal. Trying to weaken these defenses are both alliances. Good defense being played by Tiger Bots onto the courtyard. Getting lined up, trying to find their right passage over, and looking to go over the rock wall. There goes Falcon, and over the moat. Their alliance partners, Hex Hounds. Going in, tie goal shot by Falcon Robotics. That's another 5 points. Trying to weaken that tower. They have 3 shots left, the Red Alliance. 3 more boulders and they'll have the tower weakened. They got 45 seconds to do it. They got 1 down, 1 more, and another high goal. Blue Alliance trying to get lined up, pick up the balls there. And we got 30 seconds left to go in the match. Coming down to the final 20. Robots can try to hang or just surround the tower. There we go. 1 to go for the Red. Blue Alliance 32-44 trying to hang on it. 5 seconds. 4, 3, 2, 1. Red Alliance successfully surrounds the tower, challenging it. 5 points for each of those robots. Final score for qualification 3 is 138-87. Red Alliance the victor.
Drivers behind the line in 3, 2, 1, charge.
Woo! Flying over the rough terrain. The Blue Alliance 25-55. Beastbot. Oh, just misses a high goal and a low goal. Red Alliance takes it by 2 for the autonomous. And here we go in tally-up. This is the 3rd match between these two. The winners will advance to the semifinals. Falcon Robotics puts up a high goal. That'll be worth the 5 points. Their alliance partner, Hex Hounds, trying to put in a low goal, going over the rough terrain, the Red Alliance. Blue Alliance, Pi Robotics puts in a low goal for 2 points. and weakening that tower. It's a close match here, 39-39. Both teams weakening the defense and up high. 54-34, Falcon Robotics. That could be the differences in this match. The high goals versus the low goals. And Hexhounds, they're going in for a low goal shot. On the blue side, we got 42, Pi Robotics turning in a low goal shot. Blue Alliance right now has a slight lead with 60 seconds to go in the match. Blue Alliance has breached their defenses. Red Alliance is still working on theirs. Red Alliance has now breached theirs for 20 points. We have 45 seconds left to go in the match. It's tied up again at 88-88 with 35 seconds to go. Red Alliance scores high for 5 points. Blue Alliance looking to score low for 2 points. Defense being played over there. We're coming down to the last 20 seconds. Each one of the robots is going to challenge. Red Alliance has got 15 points with that challenge. Blue Alliance is trying to get all their robots back into the challenge. They got 10 seconds to go. 10 seconds to go. Gear, oh, they get loose. 4 seconds. 3, 2, can they get on? Done. Oh, no. Challenging the tower could be the difference. Very close. The winner of the match will advance to semifinals. It's the Red Alliance, 113-105.